I'm going to construct a parabola as an envelope. That is, as the curve tangential to a family of straight lines. First of all, I'm going to specify the coordinate location of these 3 points. First one is at -1/2. The second is at 0 -1/4. And the third is at 1/2. Now I'll need to zoom in on that. These have shrunk down a bit. And then I will hide the coordinates so they don't get in the way of what we want to look at. So I'm now going to create a line segment, and I'd like this segment to move, the ends of this segment to move up and down the existing segments at the same speed. So I've specified the parametric location on the line, that's the proportion along the line, to be the same in each. And we see as we move one, the other moves in conjunction. So now to create an envelope, I use the locus envelope command, and we see we've got a curve which is tangential to the entire family. First, I'm going to hide these markings so that we can get a better view. We see that curve is tangential to every position of the line. Now, if we put a point at parametric location S on the curve, let me change the S to T, and we can see that that defines the point which is tangential to the line at parametric location T. So first of all, let's have a look at what the actual equation of the curve is. Have we indeed created a parabola? And the answer is yes. In fact, it's the parabola y = x². So next, what I'd like to think about is whereabouts on the line segment is this point F, is the point of tangency. So I'd like to find out how far along the line segment DE is that point F. So I'm looking at the ratio of the distance DF to the distance DE. And I find that ratio is T. So we could have an alternative way of constructing this curve. Instead of doing it as an envelope, we could position F at parametric location T on the line, at proportion T along that line, and then take the locus of F. So let me do that. This is the proportion along line constraint. We see it down here, and put it proportion T along that line. And now what we need to do is take the locus of that, of the point F as T varies. And we see that certainly looks like the curve we had, and it looks like the envelope, but let's just check to make sure that the equation is the same. So we take the equation of the curve, and indeed it is the same, y = x². So there's two ways of constructing the parabola.